All right, so today we are talking about the Unit 3, Day 11 notes. All right, so the bell work asks us to remember how evaluating works. Are the following inequalities true when x equals 2? Well, this x equals 2 means to replace all of your x's with 2's. So this is going to be 2x minus 8 is greater than negative 3x plus 9. And this is all just calculator magic, right? 2 times 2 minus 8, that can go in a calculator. It turns out to be negative 4, is greater than negative 3 times 2 plus 9 makes 3. So negative 4 is greater than 3. Well, that's not true because no negative number is bigger than any positive number. So this is not true, which means it is not a solution. 2 is not a solution to this. It doesn't make it turn out to be true. So let's do the next one, and I'll change color so it's a little easier to tell. We're still going to replace all our x's with 2's. So negative 1/2 x plus 7 is less than or equal to 2x plus 2. So same deal, calculator magic. This side turns out to be 6, is less than or equal to, this side turns out to be 6. So 6 is less than or equal to 6. Well, that's true. It's the equal to part. 6 is equal to 6. So this is true, which means it is a solution. It does make this turn out to be true. All right, so let's go down here and let's talk about the freshman bit of this, the 9th grade, the Algebra 1 bit. And that is graphing linear inequalities. So we're going to do this on a whole graph instead of just one number at a time. So first off, I wrote in green what each of these things are. This guy, when you read him out loud, is less than or equal to. Down here is less than, greater than, and greater than or equal to. Write those in if you forget which one is which so that you have that as a reference. Okay, when we talk about lines, we're going to draw the line for when we graph it, and then we're going to shade in the side where all of the solutions are, anything that would make it true, so that we don't have to just try all of them. So the less thans are going to be shaded below the line, which kind of makes sense. If we want something less than it, anything underneath it is going to work. And so conversely, all of my greater thans we're going to shade above. All of the solutions, all of the things that would make it work are going to be above that value. When we talk about solid and dotted lines, the things that are on the line themselves might be solutions or they might not be solutions. So we use solid lines for the equals ones. So anything that actually is on the line is going to be a solution if it's got the equal to bar on it. The same way that up here in the bell work, 6 equals 6, so that value does work. So for things that are just less than, so if it's on the line, it's not going to work, we're going to use a dotted line. So you can still see the boundary, but you don't get confused and think that anything on that line is going to be a solution. All right, so let's jump to the first couple examples. It says graph the following linear inequalities. So we know most of this. The first one is y equals negative 2x plus 5. And we remember that it's mx plus b. So negative 2 is our m, or our slope. 5 is our b, or our y-intercept. So we're going to start at the y-intercept always. So we're going to start by putting a dot at 5. Positive 5 on the y-axis since it's a y-intercept. The slope is negative 2, and that is secretly negative 2 over 1 because you always need a fraction. So that says go down 2 and over 1. And I'm going to do that a couple times so I can do that so I can get a really nice straight line out of it. Down 2 over 1, up 2, backwards 1, those are the same. Okay. So now what I'm going to do is I'm going to look at this symbol right here because it's not an equal sign. If it was an equal sign, I'd just connect the lines and be done. But this is a less than sign. And if we're thinking about this chart on the back here, a less than symbol says that everything below the line is a solution. So we're going to shade under it, and we're going to use a dotted line to connect them up. So we're going to go here. We're going to use a dotted line. Really nice and spaced out so that you can tell that it's a dotted line. And then we're going to shade under it. So the side that's under is this whole side. So any coordinate point that lands in this side of the graph is going to be a solution. And hopefully you do a little bit better job coloring in than me. All right, so let's talk about the next one over here. So same deal, we're going to find our slope, and your slope is always the coefficient of x, and your b, which is always the constant or the number without an x. So we're going to start at -4, which is there. The slope is 1/3, so that is up 1 and over 3. Up 1 over 3, up 1 over 3, up 1 over 3, down 1 and backwards 3 as well, so that you get a really nice line. All right, we're going to look at this symbol right here. That is a greater than or equal to symbol. And if we go back here, greater than or equal to says we're going to shade above it, and we're going to use a solid line. So if we come here, a solid line to connect them, and we're going to shade the top half of this line. So any coordinate point that falls up here is going to be a solution. Next, it says we're going to need to put these into Edulastic. And it's not that it's hard, but it does take some explanation. Go ahead and pause this video right here. Pull up the Edulastic assignment. It's called Edulastic Examples. And let's go through it from there. All right, so hopefully you have found this. This is the first problem in there. And you'll notice that this is asking us to graph the one that we just did, right? So we're going to start with a line always, because you still need to graph it. We said that this one started at 5, so click once at 5 to get it started. And the slope was -2 over 1, so that's down 2 and over 1. As soon as you click your second dot, it will give you the whole line, and it's nice and straight since it's a computer. Okay, these next buttons, this dashed button turns your line solid or dotted. Well, we know that this line needs to be dotted because it's just less than. So if you tap on the line, sorry, touchscreen. Sorry. Okay, so click on the dash, and if you tap on the line, it will turn it dotted. If you did not want it dotted, you can click on the line again to turn it solid. But we need this one to stay dotted. Okay, and then we need to shade it. So if you click on the area button, it's going to shade in the side that you click on. So we want this guy to be shaded down here. So I'm going to tap on the area button and click anywhere on the underside of the line, and it will go ahead and shade in this whole side. You only need to tap it the once. If you accidentally tap on the wrong side, just click on the undo button and it will undo it for you. If you need a full restart, just hit the reset button. All right, so there's one done. Let's talk about the next one. So same deal, we're going to start with the line. We already did this, so it starts at -4, goes up 1 over 3. This one, since it's greater than or equal to, needs to stay a solid line. So I'm not going to click on this dashed button at all, but I do need to shade the top half. So I'm going to find any place on the top and click it, and it will shade in the top half for me as long as I have that area button done. Okay, so back to our notes. So we can go backwards too. If you already have a picture of the graph, you can figure out the slope and the y-intercept, and then you can look at the shading and the type of line to figure out the equation. So don't forget that you need to always choose good coordinate points. The y-intercept is always easiest to start with because it's on the y-axis. So this is going to start at -2. Now what we need to do is we need to find a nice happy coordinate point, so a place where it crosses at nice whole numbers. So I see this one right here, and that looks like it goes up 3 and over 3, which is just +1 if you reduce it. 3 over 3 is not wrong, but it's not reduced. Okay, so normally the equation is y equals mx plus b, or 1x minus 2. You don't have to write the 1 in front unless you want to. But I shouldn't use an equal sign because notice that there's shading going on here. So this is a dotted line, and it is shaded above. And if I think back to the front side of my notes, a dotted line that is shaded above is a greater than symbol. So it's going to be y is greater than x minus 2. All right, let's talk about the next one. So same deal, I like to look for my y-intercept first, and that looks like it is at +3. Now, for slope, we've got to find a nice happy coordinate point. I like that one right there, and it looks like it is down 4 and over 1. Or just -4, right? Because reducing. All right. So normally it would be y equals mx plus b. But in this case, I shouldn't use an equal sign because there's shading. This is a solid line, and it is shaded below. And if we look back at our notes, solid line shaded below is less than or equal to. All right, so for this next one, we're going to pause the video, try and solve it yourself on your paper, and when you hit continue, then I'll go ahead and pop up the answer. All right, there you go. I hope you got them.